Hey everyone, this is Unit 3 Notes number 21. We're pretty much wrapping up the unit circle here. So by now you've had at least 3 or 4 occasions of practicing that unit circle, right? Actually, you've had like the entire semester to really practice trig functions. So um, today's another day to really strengthen that. And if you don't feel comfortable, don't worry. Okay, you're right where you need to be. You just need to practice more and more. Okay, we try to use the unit circle as a reference. Um, by now, you should know how to use the unit circle. So now we're going to kind of graduate from there and try to have that unit circle embedded in our heads so that we can compute. So I'm going to show you how to do that. Okay. So here we go. Here's our FLT. Go ahead and press play whenever you're ready. So we're going to focus on evaluating any type of trig ratio. So this opens it up to all 6 trig functions, okay? So we'll kind of revisit that as we go. But here we go. Here's example 1. Find the exact value. While rationalizing the denominator as needed. Okay, so that's generally the directions that you'll see there. But we'll do a bunch here just to get you a little bit comfortable. So here's part A. Let's go ahead and do cosecant of pi over 6. All right. At any time with these examples, if you want to pause and try it on your own, go ahead and go for it, okay? Okay, so here's the thought process. The first thing you want to ask yourself is, where am I? Which quadrant am I in? So in your mind, here's your little thought bubble. My thought bubbles are getting better and better each time. Not really. You're thinking about your quadrants, okay? Pi over 6 has nothing at the top except for a pi. So that tells you that you're somewhere in quadrant 1. But specifically, you're at that first location right there at pi over 6. Okay? So, then you remember the coordinates there. Okay? You could look at the unit circle if you need to. So in my mind, here's what I'm thinking. I know that cosecant is the reciprocal. So when it's the reciprocal, I just do 1 over the sine of pi over 6. Okay? So remember in that last video, or the last 2, I taught you the one trig ratio that you need to know is the sine of pi over 6. Because everything else is a pattern, okay? I know that sine of pi over 6 is just 1/2. So if cosecant is the reciprocal, 1 divided by 1/2 is the same thing as 1 times the reciprocal. So 1 times 2 over 1. This pretty much comes out to a 2. And since we're in quadrant 1, I know it's going to be a positive 2. Okay? Remember, as long as you know the sine of pi over 6 is 1/2, or anything over 6 for sine, comes out to some version of 1/2, everything else will follow. Okay? Remember that anything with sine or cosine with some version of pi over 4 always comes out to some version of radical 2 over 2, whether it's a plus or a minus. Okay? So if you know, for instance, if you know that sine of pi over 6 is 1/2, cosine of pi over 6 will definitely have to be the other one, which is radical 3 over 2. So you compare it to the one that you know. Okay? More of that in a second. Here we go. Let's go ahead and jump to part B. Let's go ahead and do cosecant of pi over 3. I actually want you to pause here and try this out on your own. and then press play when you're ready. Okay, so I know that pi over 3 is definitely somewhere in quadrant 1. So I know my answer will come out positive because all trig functions come out positive in quadrant 1. I know that cosecant is really just 1 over, or the reciprocal of sine. Okay. I know that the sine of pi over 6 is 1/2. So the sine of pi over 3 should be the other one. So that's really just radical 3 over 2. Okay? Dividing by a fraction is the same thing as multiplying by the reciprocal. So 1 over radical 3 over 2, if you flip it, that becomes 2 over radical 3. But remember, we want to rationalize the denominator. So we want to make sure that the square roots are not down below. So pause here if you need to refresh on how to quickly rationalize it. I showed you the logical way and as well as a shortcut to figuring it out, but go back to your videos if you need to. 2 over radical 3 is the same thing as bringing up the radical and leaving the radicand at the bottom. Remember, the radicand is just everything on the inside of the radical. Okay? And I know that this comes out positive. Positive isn't necessary, but I'm going to put it there just to show that I checked it. Okay? Okay, let's keep going. Here's part C. Let's kick it up a notch. Let's say we did tangent of pi over 6. Okay, go ahead and try that one there. Press play whenever you're ready. So I know pi over 6 is in quadrant 1. So I know my final answer is going to come out positive something. Okay? I remember that tangent is sine over cosine. So I'm going to think tangent is sine of pi over 6 over cosine of pi over 6. So Mr. Lee taught me that sine of pi over 6 is the one that I need to remember is 1/2. So the cosine of pi over 6 can't be the same thing because sine and cosine are always different unless they're at pi over 4. Okay? So cosine of pi over 6 will come out to radical 3 over 2. So how do we divide fractions? That's the same thing as multiplying by the reciprocal. Okay, so KFC, some of you like to call it that, but I personally don't. But whatever works, right? So I noticed that the 2's will cross reduce right there. I'm going to be left with 1 over radical 3, but remember, we can't have a radical in the denominator. Well, I shouldn't say you can't, but it's preferred that you don't. So to rationalize that, that becomes radical 3 over 3. You could put that invisible 1 there if you'd like. But there you go. Okay, so these problems here, we focus primarily in the first quadrant. It's really not that different when you jump into other quadrants there, okay? So let's try a couple more. Here's part D. Let's go ahead and try secant of 5 pi over 6. Try it on your own if you'd like. Press play when you're done or if you need support. Okay, so the first thing you want to do is identify where you are. So 5 pi over 6, I know the 5 is 1 less. And if I'm 1 less, I know I'm definitely somewhere in quadrant 2. I'm somewhere in quadrant 2, so I'm right here. Okay, so I know that quadrant 2, all students take calculus. Sine is the only thing that's going to be positive. Okay. I remember that secant is the reciprocal of cosine. Okay. So since I'm dealing with cosine, it's definitely not going to come out positive because I'm in quadrant 2 and only sine is positive. So I know my final answer is something negative. I'll just leave that there so I don't forget. Okay. So I'll draw you a little bubble again. In my mind, I remember that sine of pi over 6 is some type of 1/2. Okay? Now, you don't really focus on the numerator. As long as it's something over 6, they behave the same way. So this is definitely cosine of something over 6, so I know it can't be 1/2. So it has to be the other one, which is radical 3 over 2. Okay? So if I divide by radical 3 over 2, I end up getting 2 over radical 3. You multiply by the reciprocal, so you just flip that fraction. And since I can't have a radical, or I prefer not to have a radical in the denominator, I'm going to go ahead and rationalize it. So I bring up my radical, and I divide by the radicand. And I already put a minus there, so I didn't forget. But there you have it. Okay? Hopefully you get a little bit more confident each time, but let's keep going. Here's part E. Let's go ahead and do cosecant of 7 pi over 4. Try that one on your own. Press play when you're ready. So where am I? 7 pi over 4 looks like that's double minus 1 of the denominator. So I'm definitely in quadrant 4. So I know it's all students take calculus. C stands for cosine. So cosine will be positive there. I remember that cosecant is the reciprocal of sine. Okay, so since we're dealing with sine here, I know that in the fourth quadrant, sine cannot be positive because cosine is positive here. So I know my final answer is going to be something negative. All right. I know that the sine of pi over 6 is 1/2, but more easily, whether it's sine or cosine, anything over 4 is some version of radical 2 over 2. So this is going to be 1 over radical 2 over 2. So how do I clean that up? If it's 1 divided by a fraction, I just need to flip that fraction. That'll become 2 over radical 2. But I prefer to rationalize, not have a square root in the denominator. So I bring up my radical and I divide by my radicand. I notice that the 2's on the top and the bottom from the outside can divide out to 1. So I'm left with just the square root of 2, and I know it's negative because cosecant will come out negative in the fourth quadrant. Only cosine will come out positive. Okay? Let's do F. Let's do the cotangent of 4 pi over 3. Press play when you're ready. So where am I? 4 pi over 3 is 1 more than the denominator. That happens when you're in the third quadrant. So I know I'm in the third quadrant here. So it's all students take calculus. So tangent will come out positive. I know that cotangent is just 1 over tangent. Okay, so I know that since I'm dealing with tangent and I'm in the third quadrant, my final answer will come out positive. Okay, now remember that tangent is really sine over cosine. When you're dealing with tangent or cotangent, it does take a little bit more thought because you're dealing with a lot of parts here. So here, it's the same thing. You're going to have 1 over something over something. Okay? So first, let's deal with sine of 4 pi over 3. Okay? I know the one thing Mr. Lee taught me was that the sine of pi over 6 is 1/2. So the sine of something over 3 cannot be 1/2. It has to be the other one. So that's radical 3 over 2. And if sine of something over 3 is radical 3 over 2, then cosine of something over 3 can't be the same thing, so it has to be the other one. Okay, this looks crazy because there's a lot of division symbols. So if you look at the purple, if you look at everything in purple or highlighted in yellow here, treat that as one big fraction. If it's 1 over that big fraction, you just need to flip everything that you have in purple. So instead, 1/2 is going to be at the top, and radical 3 over 2 is going to be at the bottom. Now, how do we divide that, right? You multiply by the reciprocal. So you flip what you're dividing by. I notice that the 2's across will reduce out, and I'm left with 1 at the top and the square root of 3 at the bottom. I know that it's preferred to have a radical not in the denominator, so I bring it up. I bring up the radical, and I leave the radicand. So that's 1 radical 3 over 3. The 1 is not necessary, but I'm just going to write that there. And that's it. You know, if this is looking like I'm repeating myself, it's because I am. You guys are seeing the same questions, but now you're just dealing with more trig functions, all 6 here. So the only thing left to talk about is make sure that you brush up on your quadrantal angles too. So I'll call this part G. So sometimes you'll get something weird like cosecant of pi over 2. Okay? Pi over 2 is neither a 6, a 4, or a 3, so you know it's not in the quadrants, it's actually on the axes. So I know at the very least that on the right is 0, to the left is pi, and back to the right is 2 pi. So halfway should be pi over 2, and halfway down below should be 3 pi over 2. That's just something that you've seen, and you should remember it now, okay? So I know cosecant is up top. Even if you don't know the unit circle, you should know the coordinates of that point. I don't move left or right, so my x-coordinate is 0, but I move up 1, so that's my y-coordinate there, okay? So here we go. I know that cosecant is a reciprocal of sine. And I know that sine of pi over 2, remember sine on the unit circle are the y-coordinates. If you ever forget, if you ever confuse cosine with sine, just remember alphabetical order. C before S, right? So sine of pi over 2 is 1. So that's 1 over 1, which is just 1. Okay, 1 divided by 1 is a positive 1. So I think it's a little bit easier than all the other angles, but some people tend to forget what these angles represent. So wherever you are, practice it. Okay, let's do one more. Let's go ahead and do cotangent of pi. Let's do cotangent of pi. Press play when you're ready. I know that pi is to the left. I'm going to use the same graph here. So that means the coordinates there, even if you didn't know the unit circle, that's left 1, so negative 1, not going up or down. So negative 1 comma 0. Cotangent. Now, cotangent in the previous example, I wrote as 1 over tangent, the reciprocal of tangent. But you can think of it another way. Okay? Remember that. Recall that tangent is sine over cosine, right? So cotangent, you could think of it as 1 over tangent, or you could think of it as cosine over sine. However you think of it, it'll work, okay? So I'm going to go ahead and take that option there. Cotangent of pi is the same thing as cosine of pi over the sine of pi. That pi looks funny. Okay, so I know that cosine of pi is right here. In alphabetical order, C and then S. So cosine of pi should come out to negative 1. And sine of pi comes out to 0. okay? Now, how do you divide by 0? Remember, when 0 is under, it's undefined. So there we're going to just say undefined. All right, that's it. So if you're dealing with a quadrantal angle, an angle that lies on the axes, you have to think about your coordinates, okay? I'm not too worried about that. I'm more concerned with problems like A through F. And again, it all takes practice. You know, you're not going to be an expert just by watching this video here. If you want to get really good at it, you got to keep practicing, okay? So go ahead and try to jump towards that assignment now for homework 21 on Delta Math. If you have any questions, just reach out to me.